We're going to start this puppy up. Clear, prop.
And welcome back to Tip of the Week. This week, we're going to consider what it takes to build a home-built aircraft out of wood. Now, wood has some special considerations when building, and that's what our presentation is all about. So let's take a look.
Building a wood airplane is a great choice even today. During the infancy of aviation, wood was the primary material for aircraft construction. Lightweight, readily available, and easy to work with, wood was the obvious choice for the fast pace of experimenting in aviation. As time went on, construction moved toward the use of metals as airplanes became larger and much heavier. The first step was the welded steel fuselage, but wings made completely of wood remained the norm. Even today, a walk along any flight line will find an example of a wood wing and steel fuselage still flying today. There is no real reason why wood cannot be used to construct an entire airframe. Metals with predictable strength can be consistently mass-produced into specific shapes. This is why the aircraft industry went to its use, because many copies of a particular design were being made, not just one. Remember, profit was the goal. For your one- or two-place aircraft project, wood still is a viable construction material. It is the material that most people are familiar with, and most of us have the tools available to easily cut and shape it into an enjoyable and lasting project. When completed, a wood aircraft provides resiliency to vibration and stress from regular use. Wood offers lightweight strength that can be equal to or better than metals. These facts have earned it the nickname nature's composite material. Wood aircraft do require different care than metal airplanes. Leaving it out in the elements is not a good idea. You won't have to look far or long to find an aircraft that has become unairworthy from spending time exposed to the elements. So have a plan in mind to protect your investment of time and money so it can be enjoyed for many years to come. There are many species of wood that can be used in aircraft construction, Sitka spruce being the #1 choice. But it's becoming harder to find in aircraft quality, which makes it expensive. It can be substituted with Douglas fir, western hemlock, and northern white pine. Whichever species you choose, you'll have to grade each piece to determine if it's aircraft quality and appropriate for its use. The verbal wars still continue today in discussion groups as to what type is best or cheaper to use for a particular use, but the final decision is yours alone to make. Because of the cost, some wood species are better suited for specific placement in an airframe because of less expected stress from compression or tension. On the other hand, only a specific quality of a certain wood species is acceptable to be used in places like spars and fuselage longerons. You'll need to research this subject extensively. One source will not have all the answers. A good starting point is the Experimental Aircraft Association and a local chapter in your area. They can offer you assistance with all aspects of aircraft construction with experienced builders, technical counselors, and affordable publications like this one. It contains plenty of information about types of wood for aircraft, grading its quality, and proper construction techniques. To simplify this process, you can purchase Sitka spruce from a reputable aircraft wood dealer and grade it yourself when it arrives. But just because you purchase Sitka spruce from an aircraft wood dealer does not mean that it has been graded and certified for aircraft use. you will have to examine each and every piece and determine its airworthiness for your use. One big advantage is that it can be ordered in the length and dimensions you need, eliminating the chore of milling locally obtained lumber. With all that has been said up to this point, you should not be discouraged from building an all-wood airplane. This is not rocket science. You do not need an engineering degree to figure this all out. Common sense with the right information will give you the confidence to make the right decisions. Seek out this information and make it yours. It's available and easy to find. Let's take a quick look at grading wood. These are only a few of the major parameters to be followed. It will help you identify potential boards at the yard that might pass all the criteria for aircraft use. When choosing a piece of wood for your aircraft project, start with how many annual rings per inch. Your research will define the minimums for that species of wood that you're grading. Remember, these are minimums. More rings per inch is much better. Less rings per inch means fast growth over a short period of time. Great for the lumber company who wants bigger trees in a shorter period of time, but not so good for strength in your aircraft. Tight grain means shorter growth period each year and many years to achieve its dimensions. Make sure you count the annual rings all over the entire board. Deviation might suggest unseen knots or pitch pockets inside. If your specimen meets the annual ring count, it's time to move on to the next phase. The next condition we are looking for is grain runout, or slope of the grain on the entire board. As a rule, looking at the top of a particular board, you want the grain as straight as possible the entire length of the board. The same on all sides. The distance between each grain runout should not be less than one ring within 15 inches of the length. This is much more complicated than this simple definition. Now, your research into grading wood for aircraft will reveal the math formulas needed to calculate the slope of the grain for the entire board at different locations. This is necessary to ensure that it's airworthy. Only use this information as a basic understanding to the entire process of grading wood. The next major parameter is to look for vertical grain. If this board is to be used as a solid spar or spar stock in a built-up broad U-spar, you want vertical grain. This also applies to longerons in a fuselage. You want a minimum of 45 degrees between the outer face of the board and the end grain. Anything less is not acceptable. More than 45 degrees is better. This angle must be kept more than 45 degrees the entire end of the board. In other words, the bottom cannot be at 35 degrees and the angle at the top be at 64 degrees. 45 degrees is the minimum for the entire end of the board. It will be hard to find vertical grain lumber at the yard. Lumber companies cut up logs to get the most board feet they can from a single log. They are not concerned with grain orientation. Lumber milled for aircraft, musical instruments, and fancy architectural beams are carefully planned for milling to produce boards with correct grain orientation. This can waste some of the log, but produces very high-quality wood that commands the higher price. You will find most lumberyard boards are flat grain or slash sawn. If this is the case, it's not good as a wing spar. But this board might be a candidate for spar stock in a built-up spar or for longerons if the board meets all the criteria of grading and is thick enough as the plans call for. One might ask, can't you just cut and stack them together with glue into a beam of vertical grain? The answer to that will come later in this program. Maybe by now that higher-priced Sitka spruce from the Aircraft Lumber Company isn't such a bad deal after all. But you can still find good quality alternatives if you spend the time and effort to find it and grade it yourself. Many people are doing it today, so can you. Want to start a never-ending discussion? Just walk into any hangar and ask, what glue is best? And you'd better find a chair. It's going to take a while. Let's start right off and eliminate the ones you do not want to consider. Now, these are great glues and adhesives. They're available and advertised to the general public as being the greatest ever. If you're building furniture, a house, or a bird feeder, they are fantastic advancements in the field of adhesives. However, they do not belong in your airplane, period. Here are a few glue joints on a completed wood airframe that sat for 7 years protected in a hangar. This airframe never flew, but every glue joint and lamination came apart just from sitting there. Aircraft adhesives or gluing techniques were not followed. Now, this aircraft sat outside for 2 years in Illinois and is no longer airworthy. But look at the glue joints. They are still intact, just the wood around has started to deteriorate. These are good reasons to use the proper adhesive and techniques when building a wood aircraft. There are only a handful of glues and adhesives for wood aircraft construction. You can get them from any aircraft supply dealer. Some have a shelf life and require mixing water or an activator with a powder or other liquid in a specific mixing ratio. Others are as simple as a 50-50 mix, and you just stir it up for a moment before using it. The key word you're looking for is structural. Today, the most widely used and accepted adhesives are the structural epoxies. Simple to mix and use, impervious to water, mold, petroleum distillants like gasoline, and will not soften or change with temperature. Read carefully about each adhesive. Each one has limitations or conditions that might not be suitable to your needs. The popular structural epoxy T88 has a wide acceptance among wood aircraft builders. It has proven itself over the years and should be on your list for consideration. Right now, let's head into the shop so we can show you some of the proper wood gluing techniques. The first major project is building a flat and level work table. 4 foot by 16 foot is standard. 2 4x8 sheets of heavy ply end to end should be large enough for most fuselages and wing panels. It needs to be strong, but most important, completely flat and level. Another handy item is a fence on your work table. Ours is made of 1x2 oak, pre-drilled for long screws, attaching it to the work table. Just snap a chalk line and place a screw each foot of length. It also must not move because pressure will be against it. Plus, your measurements are going to be made from this straight line using your square. Next, draw full size from your plans the placement of each wood piece, in this case, a fuselage slab side. Take your time and be very accurate. Then it's time to cut all the uprights and cross members. Again, be very accurate with your measurements and all cuts. You don't want to have any space from a bad angle cut and expect the glue to fill it. The more glue surface, the stronger the joint. Another thing to remember when cutting up the wood pieces, make sure that all members are the same dimension. If it's called for 3/4 inch square, make sure all sides are exactly 3/4 inch. A lot of time, the lumber at the yard is not exactly 3/4 of an inch. Use a planer to achieve correct dimensions for all the wood members. Don't sand the glue surface to a correct angle. Sanding will fill the grain, making it harder for the glue to penetrate and make good contact with the wood fibers. This will make your glue joints weaker. This is why it's very important to be accurate when you saw. Once everything fits like a glove, it's time to secure each wood member into place so it cannot move. You can use 1x2 oak cut into 1-inch blocks. You'll need lots of these, pre-drilled for screws, and attach them to the work table holding each member in place. Remember, you'll use this jig for the other side of the fuselage, and the entire side needs to come straight up out of the jig, so not too tight a fit. it might be a good idea to make the blocks a little thinner than your wood members. Once you lay your plywood gussets or slab side in place, you don't want glue to touch the block or interfere with the ply lying flat on the longerons or cross members. Now, to secure everything in place, you can use the same oak blocks with a 1/4-inch bolt. Drill a hole a little undersized and let the bolt make its own threads in the hardwood. Once in place, like the other blocks, you can apply pressure at the right area once the glue and member is in place. Be sure to put protection between the bolt end and the wood member. Always make sure that you have wax paper under the glue joint, or you'll find that your airframe has become a permanent part of your work table. The wax paper will peel off easily after the glue has cured. Now it's time to mix up a batch of epoxy. To achieve even spreading of the epoxy, you can use a small brush and cut it down to make it stiffer. This will make it much easier to quickly spread an even coat over the glue area. Remember to coat both surfaces to be glued. Once the two are put together, add the necessary pressure to the joint and squeeze out some of the epoxy. Make sure that you don't put too much pressure and squeeze out all of the epoxy. All that is left is wipe off the excess. It only adds weight and can get in the way later on during the building process. Plan to glue the entire project at the same time. Work fast but steady and without interruptions. This is why it's important to have done everything beforehand. Once everything is glued and double-checked for correct placement, it's time to walk away from it and let the glue set. 24 hours should be enough, but remember, most glues and epoxies take several days to completely cure. After 24 hours, you can gently remove the project from the jig and set it aside to continue to cure to its full hardness. Laminating wood to create forms like bulkheads, cantilever spars, and even longerons can be easily accomplished. The process involves jigs, even pressure along the joint with proper wood grain alignment. All surfaces must be even and flat. Structural adhesives work best when the fibers of each piece are close together. Don't expect the adhesive to fill voids along the joint and still maintain its strength. When laminating wood, you also want to glue grain to grain. This will provide the best strength for a laminate. The question was asked earlier, why can't you stack vertical grain pieces of wood and glue it into a spar or beam? It can be done, but it will not offer the strength that you would expect. The adhesive must bond the wood fibers securely. Laminating grain to grain has proven to be the best way to go if strength is required, like in a spar. However, if the top and bottom pieces of a laminated spar are large enough to carry the compression and tension loads, there should be no reason why you could not laminate a spar together of vertical grain members. Generally, the top and bottom inch of a solid spar are handling the majority of the compression and tension loads. What's in between is more for maintaining shape of the beam and adding extra weight. The key is to calculate the specific loads expected on the top and bottom pieces. This will determine their thickness and their width. If working from plans, the designer should have calculated this for you. Any wood aircraft structure will require some plywood. Some designs only call for small gussets at glue joints. while others use ply to cover the entire structure. But the practice of gluing it into place is still the same. Now, before we go any further, we're talking about aircraft plywood. It is specifically manufactured for aircraft, but is also used extensively in furniture, cabinets, and boat building. It's readily available at a reasonable cost considering the quality and its expected strength. High-quality multiple wood veneers are glued together with a process to provide high shear strength. All the cores are of equal quality, and the adhesive will withstand hours immersed in boiling water for a considerable time. The plywood in your aircraft provides shear strength. It is vital for the airframe to handle the G-loads placed on it. Just a reminder, this is all going on while you're riding in this airframe 1,000 feet above terra firma. Not a good time to test someone else's theory that door skins will handle this shear. There are some out there who advocate the use of door skins as a cheaper substitute for aircraft ply. Door skins are not manufactured to handle shear. They're made to skin an interior door and look nice. Door skins are made with much lesser grades of veneer. Just compare door skins and aircraft ply from the outside. There is a very big difference. Even the glue is not up to the chore. It might look good once varnished, but it's not aircraft quality. We're boiling a piece of door skin and a piece of aircraft birch. After just 10 minutes, the door skin comes apart easily, while the aircraft ply stays intact but is pliable. Okay, let's get back to gluing aircraft plywood. It is a little different. Unlike other woods, the plywood needs a light sanding before gluing. Sometimes in the manufacturing process, residue or wax might be on the outer veneer. A light sanding with the grain of the glue area with garnet paper will remove any possible film, and it opens the grain to receive and absorb the glue. Don't use the oxide or black type sandpaper. Be sure to clean off any sanding dust before applying the glue. Those tiny bits of debris can interfere with the two surfaces coming close together. Now, studies with gluing aircraft plywood have proven that the shear strength increases 43% just by a light sanding of the aircraft plywood before use. Again, research pays off. Grain orientation is important with aircraft ply as well. For the slab sides of a fuselage, the grain should run front to back of the airframe. This same rule applies to gussets. Now, if you're working from a good set of plans, the grain orientation should be noted in each area or situation. When gluing ply into place, even pressure is mandatory. This will allow transfer of loads from one wood member to another and not create a weak spot. Even pressure can be accomplished with weights, staples, or aircraft nails. The aircraft nails can be left in, but this old-time practice is rather archaic and should be avoided. If you must use aircraft nails, you can remove them after the glue sets by using nail strips. The same would apply to staples as well. Now, a large box of popsicle sticks comes in real handy for this. Using weight has an advantage of not driving something into the wood fibers like nails or staples that weakens the wood. But without securing the ply into place, the ply can slide around a bit and off its intended marks as the glue slowly pushes out. It might be perfect when you turn out the lights, but when you get back to the shop in the morning, your ply is stuck in the wrong place. Make plans for this by securing the ply in place with a staple in each corner. Make sure you evenly apply the glue to get equal squeeze out from the joint. Wipe off any excess when possible for a nicer appearance and less weight. Equal glue squeeze out indicates good pressure and adequate glue along the entire joint. We hope you've enjoyed this quick look at the techniques of building a wood airplane. Again, we emphasize the importance of you making the effort to research the subject before you make any decisions. A lot of time, money, and experience have been spent documenting the information you need to complete a safe and enjoyable project. Your first objective is to obtain it and then use it to your advantage. That is what you've done today. Just viewing this program has brought you one step closer to fulfilling your dream of personal flight. The ultimate satisfaction of your first flight will be the thrill of a lifetime. But the building process will provide months and possibly years of unequaled contentment and pride. The journey begins today.
And there you have it. If any of you are interested in the peat and pole wood design, we have a previous tip. The link will be below. If any of you are currently building with wood, leave some comments down below so that our other builders can understand whether you think it's a good idea to be building an aircraft from wood. If you're already involved in an aircraft project, then it's very simple. Back to building.